right, so now we're going to be adding with unlike denominators. So these are denominators that are not common, they're not the same. So we're going to take a peek, and we've got 7 over 9x squared plus x over 3x squared plus 3x. So we can go ahead. There are two different ways to solve this problem and to add them. The first one is to use the definition for adding rational expressions. What that says is that if I have a over c plus b over d, these are just any two setups. In order to add them together, I do AD plus BC over CD. Now, easy way to just determine what I'm talking about, that's if I had 3/7 plus 4/5. That's really what I did is I multiplied this by 5 over 5 and this by 7 over 7, right? That's now CD, and this is AD and BC. So we're gonna go ahead and use that same method in order to put them together. So on this left-hand side, I'm gonna go ahead and multiply it by 3x squared plus 3x to the top and the bottom. So I'm literally just going to keep it all factored out still. 3x squared plus 3x. And then on the bottom, I have 9x squared over 3x squared plus 3x. Now on the right-hand side, I'm going to multiply it by 9x squared over 9x squared. Doing it this way will cause me to go ahead and have to reduce at the end, but this tends to be the easiest way than having to find the least common denominator or the least common multiple of the denominator. So now I have x times 9x squared over 9x squared times 3x squared plus 3x. So now I technically do have a common denominator. So I'm going to put all the pieces together under that. So we've got 9x squared over 3x squared plus 3x. And then I'm going to add. So when I go ahead and add, I'm just going to distribute that 7 and that x so then I can add it together properly. So that gives me 21x squared plus 21x. And then x times 9x squared is plus 9x cubed. So now I have it split off in one piece. So now that I'm here, I'm going to go ahead and factor everything out as I can, so then I can go ahead and cancel out so that I have my most reduced fraction. So that's as if we had like 27 over 30 and we needed to reduce it, and that turns to 9 over 10. Okay, that's kind of what we're going to be doing in this next step to put a little bit of perspective onto it. So in my numerator, I can pull out an x and I can pull out a 3. What I have left, now I'll fix the order and move this piece over to the front. Now I'll have a 3x squared plus 7x plus 7 in the numerator. And in my denominator, I'm going to go ahead and pull a 3x out of this piece also. So I have a 9x squared times a 3x times an x plus 1. The 3x's cancel, and so now I'm left with 3x squared plus 7x plus 7 over 9x squared times x plus 1. Now, this is technically where you could leave this. You could leave it as this, or you could multiply that 9x squared all the way through. But that is truly that final answer of this problem. By adding together these two pieces, we went and solved it. This is going to be the easiest way to solve the problem rather than doing with the least common denominator. But if you want to check that way out, go ahead and look at page 333 in your textbook. It is method 2. I will always show you how to do method 1 and walk you through that way because it is a lot easier in order to solve, and it connects and wraps together prior concepts you've learned.